Hey everyone, and welcome to the fifth challenge in the Ethernaut series of challenges. Today we'll be tackling the token challenge, and so let's have a read of this challenge. The goal for this level below is for you to hack the basic token contract below. You're giving 20 tokens to start with, and you'll beat the level if you somehow manage to get your hands on any additional ones, preferably a very large amount of tokens. So let's take a look at this smart contract. So it's a pretty basic contract. We have a token contract. It's called token, sorry. There's a mapping between an address and an unsigned int, which is tracking the balances of each individual address, and also a total supply here. Within the constructor, we can see that where they pass in an initial supply, and the balance of the creator will be equal to the total supply, which is also equal to the initial supply. Oh, and the total supply is equal to the initial supply. There's also a transfer method which will transfer from an address from your balance to another address with a specified value, and it requires that the balance of the message.sender to be greater than it once you subtract that value to be greater than or equal to 0. And then the balances of message.sender is subtracted, and then the balances of the to address is increased. Finally, there's a function here which will return the balance of a particular address. So how do we get more than 20 tokens here? And this may look quite hard to start with, but this is introducing an idea of a overflow, a numeric overflow or underflow. And in this case, it's a numeric underflow. And so what I want you to notice here is that the balances of message.sender is a unsigned integer. And an unsigned integer basically means that it's not signed, as in it's not positive or negative. And so what happens is when you subtract, say, 5 from 1, instead of going to negative 4, it actually loops all the way back around and becomes the maximum value for an unsigned integer. So not only does it not become negative, but it actually becomes a massively positive number. And so this is what's called a numeric underflow. So let's go ahead and put this into code, and let's see how we can solve this. So let's go ahead and make a new contract. We're going to call this token.sol, paste this in, and let's go ahead and compile. And we're good to go. All right, so now we've got that going. Let's go ahead and start our script. So our script is going to be called token, and I'm going to try moving this to the right just so we can see I'm going to put the token thing to the right actually, just so you can see the contract while we're developing the script. So as always, let's go ahead and get the token, the contract address, sorry. We'll go ahead and paste this in. Cool, and we need to update our contract name to be token, and we are good to go. Okay, so the first thing that we want to do is we know that we have 20 tokens. So if we are to try and transfer 30 tokens, let's see what happens. So in the transfer here, actually, let's just verify what is the balance that we have. So our balance is equal to await contract.balance of, and we're going to put in the player address. Then let's just log current balance, balance. So let's go ahead and run this, npx hard hat run token. Can't spell today. And so ideally what this should return is 20. Let's see. Bingo. So you can see that it's a big number, so I can just put this to string. But yeah, so you can see that our current balance in this smart contract is 20. So once we come over here, we need to require that the balances of message.sender minus the value that we choose to be greater than or equal to 0. And because if we choose a value, say 30, it's going to go into those negative numbers, but it's not actually negative because it loops back over, and then we're way in the positive at the maximum value that an unsigned integer can be. So after this, let's go ahead and call await contract.transfer, and we're going to transfer to a completely different address. So let's just transfer to, let's say, I don't know. I can't even think of another address. Let's just do the contract address because that's just the only one I can think of at the moment. And the next one is the value. So we're going to put in 30. And I believe that's all we need to do. So once this happens, so let's just log what we're doing. So console.log, transferring 30 tokens. And so then once this is done, let's go and say checking current balance. And we can just copy the same code in the same script. And I'm just going to make this balance 2. And so what this is going to do is then, okay, so we've now transferred that 30 token. Let's see what the current balance is once we've transferred those 30 tokens. And we can check our balance. So let's go ahead and run this and see what happens. So ideally, we should have a much, much bigger balance. Here we go. So you can see the current balance was 20 at the start. We then tried to transfer 30 tokens, and then we checked the current balance again, and would you look at that, we have a huge amount of tokens. And so the reason behind this, again, is around this underflow concept, which has become a huge problem, or was a huge problem. But to get around this and to make sure that you're doing safe operations in your Solidity smart contracts, you should be using the OpenZeppelin library of safe math, where instead of doing subtract like this, you're doing .sub or .mol or .div, which is functions of a custom uint type that's implemented by that library. And it makes sure that you don't have any of these underflows or overflows or divide by zeros and all this kind of stuff. It's just safe maths, essentially. Cool. All right, so let's go ahead and submit this instance. Now, I believe we should be at nonce 6. Let's give it a go. Yes, got it right. There we go. And the transaction's confirmed, and we got this correct. So I will see you in the next one.